If you've only reached level 1, you're just operating the boiler. If you've reached level 4, you're driving the profitability of the entire company. Thousands of factories operate boilers every single day. But if you ask whether those boilers are truly operating safely, the answer is often uncertain. That's because many people view boiler safety in a very simple way. If the boiler doesn't explode, then it's considered safe. In reality, boiler safety has multiple levels. If your goal is only to prevent an explosion, you're merely controlling the most basic level of risk. In actual boiler operation, there are 4 levels of safety that must be maintained. Level 1, preventing boiler explosions. Level 2, environmental compliance and safety. Level 3, preventing production interruptions. Level 4, maintaining stable steam production costs. Let's take a closer look at each of these levels. Level 1, preventing boiler explosions. Understanding the root causes. Most serious boiler explosions are caused by 2 primary factors. First, low water conditions inside the boiler. Second, excessive pressure inside the boiler. When the boiler runs out of water, the metal is no longer cooled. Its temperature rises rapidly. It loses its strength to withstand pressure. If cold water is suddenly introduced, steam can expand violently. Pressure increases dramatically and may result in a boiler explosion. If boiler pressure exceeds the design limit and isn't released in time, an explosion can occur. A boiler explosion requires at least one of 2 conditions. Either the boiler runs low on water without anyone noticing, or pressure becomes excessive and cannot be relieved. To control these 2 risks, operators simply need to complete these 3 inspections. First, check the safety valve. Lift the lever slightly. The valve should release steam briefly and reseat properly. If not, fix it immediately. Second, inspect the water level gauge glass. Open the drain valve of the gauge glass. The water level should drop, then close the drain valve. The water level should return to normal. If the water level does not change, the gauge may be blocked and must be fixed immediately. Third, test the low water sensing system by draining the level column. When the valve is opened, the alarm should sound and the warning light should turn on. The feed water pump should automatically start. Once the valve is closed, the alarm should stop and the pump should shut off. If there is no response at all, the situation is extremely dangerous and requires immediate investigation. At level 1, a boiler explosion is not a complicated accident. It is usually the result of ignoring simple but essential safety checks. Level 2, environmental safety. Since July 1st, 2025, QCVN 19:2024/BTNMT has come into effect in Vietnam, introducing much stricter environmental requirements for boiler emissions. This means a boiler must do more than simply operate. It must also meet environmental standards. Otherwise, businesses risk penalties and production shutdowns. There are 4 key emission indicators that must be carefully controlled in boiler flue gas. First, CO, which is a product of incomplete combustion, particulate matter or dust concentration, SOx emissions. Fourth, NOx emissions. These 4 factors determine whether a boiler complies with environmental regulations. Among these emissions, dust and SOx are generally the easiest to control. NOx is more challenging and must be managed through combustion control. The most difficult emission to deal with is CO. Let's start with dust emissions. From a technical perspective, dust control is relatively straightforward. The flue gas treatment system should include multiple stages such as a cyclone separator for removing coarse particles, a baghouse filter for capturing fine dust, a water spray system for suppressing any remaining particles. If these systems are functioning properly, dust emissions will almost certainly meet environmental standards. However, the issue is not whether the equipment exists. The real question is whether the equipment is actually operating correctly. One of the simplest and most effective ways to monitor performance is by checking the induced draft fan motor current. When the system becomes clogged, flue gas flow decreases. As a result, fan motor current will also decrease. On the other hand, when the fan current remains close to the design value, it indicates that the system is clear and operating normally. However, if the fan current becomes higher than the design value or exceeds the baseline value recorded when the boiler was clean, your filter bags may have been damaged. The baghouse should be inspected immediately. For wet dust suppression systems, the water must be replaced regularly. Remember one important rule: if the water is dirty, it will no longer effectively clean the flue gas. Now let's discuss SOx emissions. SOx is directly related to the sulfur content of the fuel. In practice, most biomass fuels contain very little sulfur or remain well below regulatory limits. Therefore, SOx treatment is often unnecessary. However, there are several exceptions that require attention. Cashew shell residue that still contains residual oil may contain elevated sulfur levels. Certain coal sources from Indonesia can also contain significant sulfur. These fuels require special consideration. Fuel oil is another fuel type that often contains relatively high sulfur levels. In these situations, alkaline solutions can be sprayed into the flue gas stream to absorb SOx. This method is simple, effective, and easy to control. Let's look at NOx emissions. NOx is formed through two primary mechanisms. First, nitrogen in the air reacts with oxygen at high temperatures to form thermal NOx. Second, nitrogen contained in the fuel reacts under high temperature conditions to form fuel NOx. NOx emissions are typically higher in high temperature boilers. Examples include fluidized bed boilers that use a sand bed, especially when firing high calorific fuels such as coal or wood pellets. Higher combustion temperatures promote NOx formation. Therefore, the fundamental way to control NOx is to prevent combustion temperatures from becoming excessively high. This addresses the root cause of the problem. Some systems also inject ammonia or urea into the flue gas at specific temperatures to reduce NOx emissions. Many people assume that NOx can be removed in the same way as SOx by using water sprays or alkaline solutions. In reality, NOx is only slightly soluble in water. Therefore, this approach is not effective. NOx can only be effectively controlled through proper combustion management or ammonia injection at the correct temperature. Now let's discuss CO emissions. CO is the most critical and the most difficult emission to control. The most important thing to understand is that CO is a product of incomplete combustion. CO is highly toxic and cannot be removed by conventional equipment or chemical treatment. It must be controlled at the source, through the combustion process itself. CO formation depends on three key factors. First, fuel moisture content. Second, the fuel to oxygen ratio inside the furnace. Third, combustion intensity. Among these factors, fuel moisture is the most critical. When fuel moisture is high, the entire combustion process is affected. Furnace temperature decreases. Air-fuel ratios become difficult to control. Combustion intensity becomes unstable. Therefore, maintaining low fuel moisture is the fundamental requirement for controlling CO emissions. In addition, when steam demand changes, both fuel and combustion air must be adjusted accordingly. With manual fuel feeding, achieving this balance accurately is nearly impossible. However, with automated systems such as oil-fired boilers, gas-fired boilers, or PLC-controlled fluidized bed boilers, fuel feeding and combustion air can be adjusted proportionally and automatically. This helps maintain a stable combustion process. In summary, ensuring environmental compliance for a boiler requires simultaneous control of four key factors. The dust collection system must operate properly. Fuel moisture must be kept under control. Combustion temperature must not become excessively high. The combustion process must remain stable. Most importantly, the decisive factor is not the pollution control equipment itself. It is the quality of combustion inside the furnace. Many companies invest heavily in flue gas treatment systems, yet they still fail to meet environmental standards. That's because they focus on treating the symptoms, instead of controlling the root cause of the problem. We hope this video has provided valuable insights for you. Thank you for watching.